Okay, so this is an example with a piecewise function. Whenever you have a piecewise function, it is best to start drawing it first and then evaluate the limits. Okay, so let's try to graph this. So I'm going to label this one my equation number 1, and I'm going to label this one my equation number 2. Now, a piecewise function, basically what it is, you have two different pieces of the entire thing. So you're not drawing the entire graph, you're only drawing a part of it. Okay, so there's many ways you can do this. Okay, so the first thing that I'm going to do, I'm going to draw a graph. Okay, my x and y plane. The point that I'm really interested in is this 0. Okay, so this is where I'm going to have open and closed circles. Now, whenever you have a greater than or a less than without an equal sign on the bottom, this is going to say, or we're going to have an open circle there. Okay. If you have a less than or equal to or greater than or equal to, you're going to have a closed circle. Okay, and you'll see what I mean by that. Okay, so the first thing that I'm going to do, I'm going to start working with equation number 1, so my first function. Okay, this is going to be f of x is equal to 3 minus x. Okay, so the first point that I really want to look at is at x equals 0. Okay, so that's really what I want to look at. So when x equals 0, I'm going to have 3 minus 0, and this is going to give me 3. So when x was equal to 0, so here is 0, my y was equal to 3. 1, 2, 3. Okay? And that one, remember, is going to be not that. It's going to be an open circle. Okay? Because I wrote it right here that this one was going to be an open circle. This one was when x was greater than 0. Okay? Now, let's work with equation number 2. So with equation number 2, I'm going to have f of x is going to be equal to 4 minus 3x. And then x in this case is going to be less than or equal to 0. Okay? So let's plug in 0 in here. So I'm going to have 4 minus 3 times 0. This is just going to go away, and I'm going to get 4. So when x was equal to 0, the y value was equal to 4. So x equals 0, the y value was equal to 4. And this is now going to be a closed circle. Okay, so let me draw them in different colors. So equation number 1 will be black. Equation number 2 will be blue. Okay, this will be my blue one. Okay, I'm going to write blue here. Okay, and my other one's going to be my black one. Okay, all right, so for my black one, okay, let me finish drawing it. Now, because x is greater than 0, this means that the entire graph is going to be everything that's greater than 0, which means that's going to be everything to the right of it. So this is going to be to the right. Okay, now, one thing that we can look at the slope. Okay, and notice that this is downward, so then this is going to go downward. If that kind of confuses you, you can plug in another point that's to the right of it. So let me plug in x equals 1, because 1 is to the right of it. Okay, so I'm going to have 3 minus 1. That's going to give me 2. So this is going to be x equals 1, y equals 2. So this one, my first equation, the black one, is going to go downward. Okay, so there's my first part of the piece. Now my blue one, okay, something that you can do with this one, you can plug in any number that you want. Now remember, since the x is less than or equal to 0, this one's going to be to the left. Okay, so it's going to be on the left-hand side of 0. Okay, so now I'm going to plug in any point, x equals negative 1, for example. So I'm going to plug in 4 minus 3 times negative 1. So this is going to be 4 plus 3, which gives me 7. So when x equals negative 1, my y was equal to 7. So 7 somewhere over here. Okay? And then you'll see that this graph is going upward. Okay? So this is what my graph looks like. Okay? Now, what I'm going to do now, I can go ahead and evaluate the limits. Okay, so when I take the limit from x goes to 0 from the negative side, well, I'm actually looking at the blue graph. So the blue graph, I'm going to go ahead and take the limit as x goes to 0 and see what value is that approaching. So this one's going to keep going to 0, and then the y value is going to be 4. So the limit in this case is going to be 4. Okay, now as I come from the positive side, okay, that one I'm going to be using the black graph. So I'm going to take the limit as x goes to 0 from the positive side, And what I'm going to get y equals 3. So the y value that's approaching, that x is approaching in this case is going to be 3. Okay, so the limit is 3. Okay, now in order for me to figure out the actual limit, well, I have to make sure that these limits coincide. So the limit as x goes to 0 from the positive side has to equal the limit as x goes to 0 from the negative side. Okay, since these two limits are not the same, okay, so I'm going to write are not the same, what can we say? Well, in this case, the limit does not exist. It does not exist. Okay, or you can just write DNE. Okay. All right, so you can try to do this problem on your own. It is a little bit involved, but it's still a really good problem.